This is a review for the Geometry Chapter 4 test. So, number 1, it says to use a protractor and ruler to classify the triangle by its sides, or angles and sides. You'll need your ruler, but I can tell you that the sides are not going to be the same. So it's going to be scaling. You need to make sure you measure, okay, because sometimes looks can be deceiving. And that's by its sides, but by its angles, this one is going to be, you need to measure all of these angles, and they're not the same. Okay, don't get confused because I drew those. So just the 3 angles here, and they're all acute. So it's an acute scaling triangle. Number 2, it says to find x, AB, BC, and AC if it is equilateral. So equilateral means that all the sides are the same. They're congruent, so I'm going to pick the 2 easiest ones for me. 8x equals 7x plus 3. So subtracting the 7x, I get x equals 3. So first of all, x equals 3. Now it said AB, BC, and AC. So the length of AB would be 30 minus 6, which is a 24. And then I want to just check. They should all be the same because it's equilateral. So BC 7 times 3 is 21. And then plus 3 is 24. And then AC 8 times 3 is 24. So I did it right. Number 3, find the measure of the sides of the triangle if the vertices of triangle EFG are -3, 3, 1, -1, and -3, 5, and then classify it by its sides. So I could draw the triangle, that's fine, but I am not going to. I need to know the measure of all the sides, so I need to do the distance formula on all of them. So the length of EF is going to be the square root of x minus x, so -3 minus 1 squared plus y minus y, 3 minus a -1 squared. It's going to be equal to the square root. It's going to be a 4 and a 4. So 4 squared is 16. Another 4 squared, that's 16. So I'm just going to write that down. 4 squared and 4 squared. Square root of 16 plus 16. The square root of 32. I'm not going to go ahead and take the square root, okay, but make sure you're finding the measure of all the sides. I guess I could simplify that. So this is going to be 4 square root of 2. And then we need to find the other sides. So I found EF. Now I'm going to go for FG. So that's going to be the square root of 1 minus a -3. So 1 plus 3. And then -1 minus a -5. So -1 plus 5 squared. This gives me the square root of 4 squared plus 4 squared. And again, that's the same thing, so that's going to be 4 square root of 2. Because 16 plus 16 is 32. Square root of that. And then I need to find EF. There are 3 sides, so make sure you do them all. -3 minus a -3 squared. Plus 3 minus a -5 squared. So this is 0. And so then that's going to be 8 squared. So square root of 64. That's equal to 8. 2 of the sides are the same. The third one is not. So this is isosceles. ISOSCELES, and it's isosceles. Alright, number 4. Well, 4, 5, and 6, we want to find all of these angles. So finding the measure of each angle, I know that since this is I'm going to zoom in here. This is a linear pair right here, so 180 minus 110, that leaves 70 here. So check out, these two sides are congruent, so these two angles are congruent. So angle 1 right here is going to be 70 as well. And then angle 2, it's an exterior angle. It's equal to the sum of the two remote interiors. So angle 2 is going to be equal to 140. And then I'm going to go the other way on that and say this exterior angle is equal to the sum of these two remote interior angles. So 140 is equal to 90 plus angle 3. So angle 3 is equal to 140 minus 90, so it's equal to 50 degrees. So angle 1, so number 4, I found out it was 70 degrees. And then angle 2 was 140 degrees. And angle 3 was 50 degrees. Identify the corresponding, or identify the congruent triangles and name their corresponding congruent angles. Okay, so I know that triangle, I'm going to start with ABC. It's congruent to triangle. Angle A matches up with angle F. So this is F. Keep that one red. And then angle B is congruent to angle D. And then angle C is congruent to angle G. And that's it. So I mark their corresponding congruent angles as well. So make sure you answer them fully. So identify the transformation and verify it is a congruence transformation. So this right here is a reflection. Now, in order to verify it's a congruent transformation, I need to find the length of all the sides. In order to do that, I'm going to zoom in, and I'm not going to go and use the distance formula per se, but the Pythagorean theorem. So this one's 2, this is 1, 2, 3, 4, 5, and then a squared, 2 squared plus 5 squared. So that's 4 plus 25, that's at 29. So this is the square root of 29. I'll show your work, okay? And it can be just that. Show me what you're doing. So this is 1, and then 1, 2, 3, 4. So 1 squared is 1, 4 squared is 16. So this is the square root of 17. This is 1, 1, 2, 3. 1 squared is 1, 3 squared is 9, square root 10. Now I'm going to go on the other side and make sure it matches. This is 2, 1, 2, 3, 4, 5. 2 and 5 match. So this is the square root of 29. And I'm going to go 1, 1, 2, 3, 4. So 1 and a 4. It matches. This is the square root of 17. This is over 1 and 1, 2, 3. So this is 1 and 3. This is the square root of 10. So there, I just verified it was a congruence transformation. Number 9. This is a good thinking problem. It says a rectangular piece of paper. It's measuring 8 by 16. It's folded in half to form a square. So now it's going to be an 8 by 8. And it's folded again along the diagonal here, which then now is an isosceles right triangle. And then it says find the measure of the angles of the triangle. Well, since these two sides are congruent, and this one's 90, so 180 minus 90. I'm left with 90 degrees for the other two angles. I'm going to divide that by 2 because they're congruent and they have to be equal. So each angle is then 45 degrees. Number 10, triangle KLM is an isosceles triangle, and angle 1 is congruent to angle 2. Name the theorem that could be used to determine that LKP is congruent to LMN. So it's an isosceles, so these two sides are congruent. And then name the postulate could be used to prove that the triangles are congruent. So name the theorem. So we're going to go, because they're congruent, these two angles are now, opposite angles are congruent. And that's in the big triangle, okay? So now I'm going to erase that out. And the theorem, right here, name the theorem that could be used to determine that the angles are equal. That is the isosceles triangle theorem. Because it says if two sides are congruent in a triangle, then the angles opposite those sides are congruent. And then name the postulate that could be used to prove that the two triangles are congruent, LKP and LMN. Well, let's look and see what we have marked. We have a side, an angle, and an angle. So we're angle, angle, side. Number 11, we're going to find the measure of angle 1. Now be careful here. So right here, these sides are all congruent. Because of that, these opposite angles are congruent because isosceles triangle theorem says the angles opposite sides are congruent. Now a lot of you are probably going to say, well, then these sides are congruent right here, so this is going to make this angle 40. You can't do that, okay? Don't do that. This is a triangle. There's 180 degrees in the triangle. We know that 80 of them are for those other two angles. That leaves 100 right here. So this angle right here is 100. You're like, well, I thought that looked like a 90 degrees. Don't go by what it looks like, go by what it says. So then this is a linear pair, so this angle is 80 degrees. Now, we have another triangle over here. That's 180 degrees. Minus 80 from that one, that's 100. Of course, these two angles are congruent because the sides are. So that means I have 100 degrees to split evenly between the two. So angle 1 is 50 degrees. Make sure you go through the whole triangles, not just what you think it looks like or the sides. Be careful because a lot of people do that and that makes it wrong. Number 12, find the value of angle x. Find the value of x. Right here, all your sides are congruent. So that means all the angles are congruent because then it's an equilateral triangle, which is an equal angular triangle. So pick the two angles that you think might be the easiest for you and set them equal. Or, even better yet, you know what all the angles are equal to. What are all the angles equal to in an equilateral? 60 degrees. So x is equal to 4. So x equals 4. Alright, so the next one, I'm going to say that triangle ABC is congruent to what triangle? Y. So A is between the 1 and the 3's, so that's going to match up with a G. And then B is between 2 and 3, so between 2 and 3 is N. And then C is between 1 and 2. So that's going to be T. And it's by side, side, side. Number 14. I'm looking at this, and this is angle, side, side. You can't do this one. Okay? Just because I have blanks there doesn't mean that it can be done. Number 15, it says to position and label isosceles triangle ABC with a base AB B units long on the coordinate plane. So this is what we've just done. Coordinate plane right there is not very good. But then my triangle ABC, it's isosceles. So it needs to be base AB. So here's A and here's B. So that means this is C up here. And then the coordinates, this is 0, 0. It's B units long. So my B is going to be B0. And then C, since it's isosceles, and the base is AB, that means these are the legs and they're congruent. So halfway in the middle here, that's half of B. And there's no way on an isosceles to know how tall it is, how far up it goes. We'll call it C. All right, our proof. Dun, dun, dun. It says that AB is parallel to CD. So statement 1, AB is parallel to CD. And it's given. It also says that angle CBD. CBD. So I need to draw another diagonal. So this angle here is congruent to angle ADB right here. That's also the given. So angle CBD is congruent to angle ADB. Still the given. Now, be careful. It's a little deceptive because a diagonal was drawn. You don't need that one. That was drawn for you. We need to know that triangle ABD is congruent to triangle CDB. So where I'm going to go to start with is that I'm going to go the easy route and say that DB is congruent to DB. And that's by my reflexive property. So make sure I mark it. And then I know that the lines are parallel, so I'm going to go alternate interior angles. And I'm going to say that these two angles are congruent. And I kind of knew that because when I looked at the picture, well, I had two parts. And I know I'm going to go to the triangles, so I need to go those opposite angles. So angle ABD is congruent to angle CDB, and that's by alternate interior angles are congruent. And then I have 3 parts marked on each one, so I can say that my triangles are congruent. So triangle ABD is congruent to triangle CDB. What do we have marked in the order? I have marked angle, side, angle. So my reason for number 4 is angle, side, angle.